Hey guys, today's video is about association mining. In other words, we want to generate some strong association rules from the dataset. For example, we have a supermarket data, and we want to find which items are often bought together, and we can define our marketing strategy. So to do so, we first import the package we need. And let's look at our data. So for simplicity, I'll just create 5 transactions here. So you can see each row represents a transaction. So the first person buys these items. However, if we directly convert the data to a data frame, it will look like this. Data frame, data. It's just use each cell to represent the item a person buy, but to use a priori algorithm in Python, it can only take numbers or true and false. So we have to transform the data, and we'll use transaction encoder. So we first create this class transaction encoder, and we transform our data. You can just use the function with transformed and data. And then we convert this transform data to data frame. But before that, let's see how this data looks like. So yes, this is just true and false value. It might be confusing, but don't worry, we can now convert it to data frame. df equals to pd.data frame, data transformed, columns equals to t. So here we are. Each column represents an item. If a person didn't buy the item, it will just show false. So the first person bought apple, and yes, indeed, but not bagel. And for banana, true. So yeah, we now know we successfully transformed our data. So let's find frequent item set. We'll use a priori algorithm, but we have to define minimum support. Define minimum support. So I'll just define as 0.6, but you can define your own threshold. Frequent items equals to a priori. You put the data frame here, and you put your own threshold, 0.6. And we use columns equals to true, means we will use this column name. And since the column names are just the names of items, so it's not confusing, we'll just use them. And the default value for minimum support is 0.5. So if you want to set minimum support as 0.5, you don't need to make adjustment. So the default minimum support is 0.5. Okay, let's see our frequent items. Here we go. So we can see the item set apple has support 0.6, means it appears in 60% of transactions in our database. And let's check out this. So yes, for apple column, there are 3 transactions containing apple, which is 3 out of 5 is 60%. And then we can use this to generate strong association rules. So in case you don't remember, a strong association rules has 2 conditions to satisfy. A strong association rule. So its support has to be larger than or equal to minimum support, and its confidence has to be larger or equal than minimum confidence. And then we can generate this, use the function here, association rules. So we put our frequent item set. So because we use frequent item set, it automatically satisfies the first condition. The support is larger than minimum support. And then we can specify the matrix. This is our condition. we use confidence because this is how we define strong association rules. And we can set the minimum threshold for confidence. So I'll just say yes, 0.8. And let's see the rules. So we have these 10 rules, but you can actually sort these rules by the values you want. So we want to sort it by confidence because we use confidence as a criteria. And oh no, sorry. Ascending equals to false. So you'll just start from the largest value, but in this case, all the rows has confidence 1. So the order doesn't really change, but in a case that confidence are different, the order will change. So now let's interpret our rules. So let's look at the first rules. We can write it as apple to banana. So the antecedent is apple and the consequence is banana. But remember, this is just about correlation, not causation. So don't confuse these two concepts. So we say these two item sets are correlated. We doesn't know which one causes the other. So we don't know if people who bought apple tends to buy banana, or people who bought banana tends to buy apple. We only know people tend to buy these two items together. Okay, so let's look at the support. So the support is the percentage of transactions containing these two item sets. So the first rule has support 0.6, means 60% of transactions containing both apple and banana. Okay, then confidence. The confidence is how reliable the rule is. To be more specific, the confidence is the proportion of transactions containing antecedents also contain consequence. So the confidence is 1.00, means 100% of transactions containing apple also contains banana. So let's check this out here. So the first one contains apple, it also contains banana. And the second one contains apple, also contains banana. And the last one contains apple, also contains banana. So yes, every transaction containing apple also contains banana. So the confidence is 1. And then we can look at lift. Lift is a way to measure the correlation between the item sets. So if the lift is larger than 1, the two item sets are positively correlated. In other words, the two item sets are often bought together in a transaction. So in this case, the lift is 1.25. It's larger than 1, so the two item sets, apple and banana, are positively correlated. They are often bought together. Then we can move on to leverage. The leverage is just another measure to measure the correlation between two item sets. However, it favors item sets with higher support. So be careful of this property when you use it. Okay, so to interpret this, if the leverage is higher than 0, the two item sets are also positively correlated. So in this case, the leverage is 0.12. It's larger than 0. So again, we got the same conclusion. The two item sets are positively correlated. In other words, they are often bought together. So if we look at the lift and leverage, they'll give us the same conclusion because they're kind of the same concept, just using different formula. So in this example, for the first rule, both lift and leverage suggest apple and banana are positively correlated. And we won't talk about conviction because it's not often used. So basically, that's how you interpret a rule and how you generate strong association rule based on your definition of minimum support and minimum confidence. Okay, so the code is actually not complicated, but it's useful in marketing strategy. And thank you for watching today's video. Hope you enjoy it.